Now we want to address the question of what is the y factor if it's a power function. And also, what is the power? So I'm going to take this one, okay, and before I go on, you should have already worked through these. If you're looking at this without having worked through them, you're skipping. You're probably not learning what you need to do, but maybe. I can't judge that. So make sure that you're doing what you need to do in the intended sequence. If you're not, make sure that you're doing the right thing. It's very possible you have an aptitude and a combination of skills and a focus that could allow you to do that, but it would be unusual. Most people would need to work through this in the intended or the prescribed order. Okay, so I'm going to kind of give one thing away. Now this one I think is reasonably well fit by a power function, so let's see what the power would be. So I'm going to take x values as usual. We'll start here, and then we'll go halfway, and we'll go halfway, and we'll go halfway, and we'll go halfway again. Okay? Now, we get points on the graph. So I'm going to mark the points on the graph. From here, we have this point. From here, we have this point. From here, we have this point, and now we have a point here, and we have a point here. So the question is, when I go from here to here, is the factor, what's the factor look like there? It looks like 1.5 or a little more, okay, because this distance between here and here appears to be a little more than half of this distance. Now we can draw projection lines. That might be helpful. Okay, so let's see. This point appears to be a little more than half again this point. So I'd say the factor here might be about 1.7. Now, from this point to this point, we go from here to here. The y value goes from here to here. Well, from here to here, looks like, again, well, a little less than 2. Okay? Now, from here to here, well, from here to here, it looks like maybe about 1.3. Okay, that's not very consistent with these two. Now, you notice in the original curve, and if the x is obliterating it, the curve kind of has a little glitch right here. So it appears that something changes, and from here to here, it looks again more like about 1.3 or 1.4 for the factor. So the factors aren't great. The factors range from I'd say about 1.3 to 1.8, the factors by which y changes. So this is not great. But it's better than what you get with a lot of the other graphs. So I won't say whether any of the other graphs do better than this or not. It's not great, but not terrible. Okay, so I'm going to say average factor is around, I'll just average the 1.3 and the 1.8 in saying 1.55. And actually I'm going to round that up and call it maybe 1.6. Now, factor 1.6 will work pretty well from here to here, but it's not going to work well from here to here. Okay, it's going to be a little low for the points here. It's going to be a little high for the points here. And it's up to deeper analysis and interpretation whether that actually means anything. Or do we perhaps have a split definition function where you have one power here and another power here? You can consider all those possibilities. I would say, though, the average factors may be 1.6, and if so, what would be the power? The corresponding power would be what? Log of 1.6 over log of 2. And you can figure out what the log of 1.6 over the log of 2 is. You do that in your calculator. Okay, so that would be sort of an answer for this one. You would want to analyze each of these similarly. If it's plausible, if the range of the factors is not too horribly big, then you can conjecture that maybe you have a power function, maybe not. So you can check each of the other graphs in the same way.